common multiples. This is something we can use to compare fractions later. You can also use in other areas of math, like for example, in accelerated math in 8th grade, they use the least common multiple to determine a means to cancel out a variable. You'll learn about that later. Anyways, it has a lot of uses in math, so we're going to talk about it today. First off, let's go through some vocab. So first one is multiple, is the product of a number and a whole number. So example, the multiples of 2 would be 2, 4, 6, 8, 10, 12, right? The least common multiple is the smallest multiple that is not 0 that is common to 2 or more numbers. And then the least common denominator is the least common multiple of 2 or more denominators. So the least common denominator really refers to comparing fractions. All right, so let's talk about how we can find the least common multiple. There's really 2 ways to do it. You can list the multiples of the given numbers until you find the first multiple that is common to all given numbers. Often this is a really fast technique. The second technique we can use is use prime factorization of the given numbers to identify prime factors. Identify the common prime factors, find the product of the common prime factors and the remaining factors. The whole identifying the common prime factors is just so you don't use those more than once. We'll do a couple of those later. All right. Okay, so let's go ahead and do the first example. The first example is list the first 5 multiples of 3 and 6 and then find the LCM. We're also going to do this using prime factorization. All right. Okay, so 3. Let's list the multiples of 3 first. So 3, we have 3, 6, 9, 12, and 15. Now, these go on forever, so I'm not going to keep writing forever. I'm going to stop. Okay, now let's list the multiples of 6. We have 6, 12, 18, 24, and 30. You notice that all I'm really doing is multiplying 6 by increasing value. So this is 6 times 1, which is 6. This is 6 times 2, which is 12. 6 times 3 is 18. 6 times 4 is 24. And 6 times 5 is 30. So those are all of my multiples of 5, the first 5 positive multiples. So now I want to find the least common multiple. So now what I'm looking for is the smallest number that appears in both of those lists. So 3 does not appear on the bottom list. However, 6 appears on both. So at this point, I could go ahead and say my LCM or my least common multiple is indeed 6. Now we could also do that using prime factorization. Yeah, let's do that. So 3. Now, 3 is already a prime number. So really already done, right? So 6, I have 3 and 2. Right? You notice that I have 3 circled. If I'm circling that number, that means it appears in both of them after we factorize it. That's a reminder that you can only use that once when we're using prime factorization to determine the least common multiple. So now what I'm going to do is I'm going to take the circle number 3 and then multiply it by whatever's left over. So in this case 2. So 3 times 2 is 6. All right, another way to find the least common multiple. All right, let's do the same process again. So this next one, hopefully prime factorization will make a little more sense. So let's list the first 5 multiples of 10. So obviously 10 is the first one, and then we have 20, then we have 30, then we have 40, and then we have 50. Okay, let's do the same thing for 25. So 25, think of quarters right now. 50, 75, 100, and 125. Okay, great. Those all look good. All right, so 10 does not appear on the second list. 20 does not appear on the second list. 30 does not appear on the second list. 40 does not appear on the second list. However, 50 does. Right there. So we think the LCM is 50. Actually, we don't think, we know. That's the least common multiple. Okay, now let's do the same thing using prime factorization. So if we have 10, we have 2 and 5. Okay, those are both primes, so we can stop there. If we have 25, we have 5 and 5. Okay, so now if you look at this, you'll notice that I have a 5 here and I have another 5 here, right? Which means I can only write that 5 down one time. So anytime I have a pair, I only write it down twice. But anything outside of that, I can write down as well. So now to find my least common multiple using prime factorization, I would do 2. Then I'd multiply it by my 5 that I have 2 of, the double 5. Then I go ahead and multiply it by that 5 that's all by itself. So let's do some quick math. 2 times 5 is 10, right? And then we have 10 times 5 is 50. So once again, my least common multiple is 50. All right, next example. Courtney and Keisha are cousins. Good for you. Courtney visits her grandma every 30 days. Keisha visits her grandma every 20 days. They both visited their grandma today. How long will it be before they are together at their grandma's house on the same day? Ooh, it's going to take them a while, but let's figure that out. So Courtney is every 30 days. So we have 30. So 30, 60, 90, 120, 150. Hopefully she gets to see her cousin before then. Keisha goes by 20, so it's 20, 40, 60, 80, 100. Now you're probably watching this thinking, Mr. Robinson, why don't you just stop at 60? You're right, I could have stopped at 60. The least common multiple is 60 indeed. So the least common multiple is 60. Now, let's do prime factorization. I'm going to say right now that prime factorization in this case can be a little confusing, right? But it can also be more efficient, especially if we're looking at really large numbers. So I'm going to go ahead and do this one. So we have 30, right? So I have 2 and 15, and then 3 and 5, right? So for 20, we have 2 and 10, and then we have 2 and 5. So let's circle whatever numbers we have twice. So I have 2 here, and then I have a repeat. Okay, I have 5 here, and then I have a repeat. So remember, the ones that are circled, I can only write down, so that set I write down once. So I'll write down the green numbers first. So 2 and 5 we have repeats of. And then we have an extra 2 and an extra 3. Okay, so let's go ahead and do that. Let's do some quick math here. So let's rewrite it over here so we have a little more room to work. So I'm going to drop the colors. We're just going to write them down as we have them. 2 times 5 times 2 times 3. Okay, 2 times 5 is 10. 10 times 2 is 20. 20 times 3 is 60. So once again, using a different technique, I got the least common multiple of 60. All right, here's our last example. Similar scenario, Frankie and Juliana met at the salon. They got haircuts today. Frankie gets a haircut every 30 days. Juliana gets a haircut every 40 days. How many days until they will see each other at the salon? Okay, so Frankie every 30 days. So 30, 60, 90, 120, 150. I'm just counting by 30s. I know I can do it fast. I am a math teacher. 40. Right? We start at 40, and then 80, and then 120. This time I'm going to stop because I know it's 120. It's the first number that appeared on both lists. So I think the LCM is 120. Now let's find it using prime factorization. So 30, we have 2 and 15, and then we have 3 and 5. For 40, we have 2 and 20, and then 20 we have 2 and 10, and then 10 we have 2 and 5. Okay, let's circle numbers we see that repeat themselves. So I have a 2 here, and I have a 2 here, then I have a 5 here, and then I have a 5 here. Okay, let's write down the repeaters. So I have 2 times 5, and then let's repeat down the ones that do not repeat. I have 3 times 2 times 2. I realize we have 2 here's but remember they have to repeat in both of the prime factorization trees in order for us to circle them and count them as a quote-unquote repeater. All right, now let's just make sure that that actually equals 120 to make sure Mr. Robinson isn't lying to you. 2 times 5 is 10. Now you realize I'm just multiplying from left to right following, order of operations. 10 times 3 is 30. 30 times 2 is 60. 60 times 2 is indeed, bugged out on them, is indeed 120. So there you go. Once again, you're getting the least common multiple of 120. All right, I hope this was helpful. We'll be going over this in class today or Friday, depending on which teacher you have. And yeah, Ciao.